Ready to go? Welcome. My name is Marcus Mitchell. I'm an engineering director here in the New York office. Welcome to our monthly tech speaker series. We're very excited to have Chris Dixon, co-founder of Hunch and the Founder Collective, and fixture in the New York tech scene, talking about graphs. He is a prolific blogger, and one of the entries that caught my eye a little while ago was about graphs in different contexts, social graphs, taste graphs, and so we thought it would be pretty interesting to hear him come and talk about this. I also want to draw your attention to the fact that we do this series every month. You should be able to continue to see it on posted about on Meetup, and we're going to be inviting a mix of speakers, some who work at Google, some from outside. We're very excited and very interested in any kind of feedback that you want to give us, and so come up to me or anybody who's wearing a Google t-shirt and tell us more about some of the kinds of talks that you'd like to see. Without further ado, here's Chris.
Thanks for having me. Can you guys hear me? Okay. So my name's Chris Dixon. I'm the co-founder of Hunch and also a seed venture fund called Founder Collective. And I blog at cdixon.org if you're interested. And I was excited to be invited to talk about this topic because usually I get asked to talk about like venture capital and other kinds of things which get kind of tiring, and this is, I think, much more interesting. So, and if you want to tweet about it, I propose a hashtag there. So, and so I've decided that for all my blog posts now, I'm going to have my title and then like a Malcolm Gladwell title that sounds a lot sexier. So my title's Graphs, and the Malcolm Gladwell title is What Chipotle, Glenn Beck, Alien Abduction Teaches About the Future of the Web. All right, so what is a graph? So you guys, I think this might be a more technical crowd than I anticipated, so maybe I'll try to be kind of quick with this stuff. But the simplest form of graph is nodes connected with edges, and the edges, the nodes can be, in the case of like a social network, the nodes are people, and the edges are relationship of friendship, right? In a communication graph like Skype, nodes are people, edges are people you talk to. You know, you can think of Google core search ranking algorithms as a graph where the nodes are pages and links are the edges. Sort of like links are kind of votes for the authority of a page. At Hunch, we think about what we call a taste graph, where nodes are people, or they can also be items, and the edges between them are sort of the similarity in taste. And then people call them different things, but like Twitter and maybe like something like Instagram, or sort of interest graphs, maybe aesthetics graphs, et cetera. So that's so this is going back in history a little bit here, since I always feel like in business and computer science talk, people pretend like everything began in like 1990, but in fact, there's a lot more before it. So graph theory kind of began in the 1700s with the Oilers, 7 bridges of Königsberg problem. The kind of key insight here was, so the idea was, the question you see here, is it possible to traverse the town and cross the bridge exactly once? The key insight here was to ignore the geometric properties of the town and just simply look at each landmass as a node and the bridges as edges. And so, you know, if you see on the right, that's how it's structured, and that's sort of the beginning of what's called topology, which is basically kind of like, you know, the study of shapes where you don't actually, where if you bend them and this and that, they're sort of, it doesn't matter the actual spatial relationships, it's all about just the connections between them. So graphs, they're sort of, there's sort of 2 basic kinds of graphs. One's an undirected graph where they're symmetric. So if the relationship of friendship is an undirected graph where, you know, we're familiar with on Facebook. If I'm friends with you, then you're friends with me. A directed graph is non-symmetric, so they can be symmetric, meaning, you know, I can follow you on Twitter and you can follow me on Twitter, but we can also choose to have it one way or the other. Glenn Beck follows 25 people, but is followed by 350,000. In some ways, I don't know if it was deliberate or not, but like you could think of Twitter's sort of primary innovation as being to kind of relax the symmetry constraint on the friend relationship, and I think that then led to probably a lot of emergent behavior, which ended up being what it is today, which is kind of more of like a publishing platform. You know, Facebook, people think of it as an undirected friend graph, but actually, I think, you know, in the last year they introduced the like button, and the like button has, I think, should be best thought of as sort of a interest graph bolted onto So a directed interest graph bolted onto an undirected friend graph. Okay, now I'm just going to throw in some fun data here because to keep it fun. And so this is some analysis we did at Hunch. I don't know why this. Okay, so I don't know if I've ever seen this data before. I don't know if anyone's done this, but this is accurate data, like counting lots of millions of people. So on Twitter, the average number. Well, you can see the numbers here. I won't just explain them all, but I guess of note is on Facebook, the number of likes is 30. That's actually something that Facebook wants to increase. If you see like the changes they did recently to the profile pages and all of the sort of syndicated likes and things like this is something that they've made a real big effort to kind of improve. And then the 217 is the inverse. So that's That's on average, things that are liked, Kraft or Coca-Cola or something, on average, they're liked by 217 people. But the interesting thing here is really, it's not working, the distributions. So on Twitter, so the x-axis is the number of people that, in the left, that number of followers you have. No, sorry, is the y-axis is the number of followers you have, and the x-axis is the number of people who that applies to. And so what you basically see is they're sort of like the Oprah Winfreys and the Ashton Kutchers of the world who are followed by tons and tons of people, and then it drops off dramatically. That spike there, not exactly sure what that's people you follow. I believe that has to do with the old onboarding process where they had a suggested user list and they suggested 20 people. That's, I think, but if anyone has any other theories, I'd be interested in them. I guess it would be interesting if there was a bimodal distribution. But now contrast that to the Facebook graph, which so this is the y is the number of people, x is the number of friends for those people. So you see the spike there where a lot of people have just one friend. Sort of sad, I guess. And then 2 is pretty big too. I think that has to do with the onboarding again. Like, hey, you should friend this one. Maybe like the 1 is like the person that invited them and they didn't use it or whatever. And then it follows kind of a little more like a bell curve. This is sort of reflective of if you look at actual social relationships, they tend to be more of a bell curve versus a publishing platform. So I think to me what these two slides say is publishing platform, friend, social network. And then, as I was sort of claiming before, the likes thing bolted on to Facebook is a undirected interest graph, and I think this power curve looking like Twitter kind of is evidence of that. All right. So why do we care about graphs? I'll give a couple examples from real world applications in marketing. There's a very interesting. I can't walk around with this thing, I guess. I like to pace, but it's okay. It's okay. All right. So. There's a very interesting study done by, I think it was a telecommunications company. I run video, right? So a large telecommunications company did a study where they, what they basically did was they took some product, let's call it like the Swiffer or something, and they found people that bought the Swiffer, and that's in my example, person A. And then they looked at the calling patterns of people using their phone network. And they saw that person A communicated with, person B, let's say a family member or something, and then they took person C, who was sort of someone that would be highly targeted according to kind of traditional marketing techniques, psychographic profile, demographic profile, et cetera, and they basically, called up C and B, and they of course did this at a large scale, and they said, do you want to buy a Swiffer or whatever that the person A had already bought. And so it turns out that B buys a lot more Swiffers than C. So it turns out that simply like being someone who communicates with somebody else greatly dominated sort of other traditional marketing techniques. And this was actually done long before kind of social networks and things like this, but is the basis for the ad targeting on Facebook, and also there's a lot of independent, like New York-based companies which have taken similar approaches of sort of tracking people with cookies and trying to figure out like who have who are related to each other, and if you click on whatever the ad for a Connect, and it knows that your friend who's cookied, is your friend, they're more likely to see that ad. So this is one example of a graph in action. Another one is more serious, is in defense and law enforcement. So if you can use graphs to, and this is something that's really actively done. But basically, like if you want to map out an organization, one of the things you can do, even if you don't know the contents of the communications between the individuals in the organization, and all you simply know is that A called B and B called A back. So when your boss calls, you call your boss right back. When the subordinate calls, the boss might take a data call back. So from patterns like that, and there's other more sophisticated patterns, you can kind of map out that in that case, A is the boss and B is the henchman. And you can imagine sort of iterating through this and doing it for large organizations and figuring out like this terrorist cell or mafia organization, et cetera. Actually, there was a study done using something like World of Warcraft that where researchers tried to do this and figure out the structure of the I don't know what you call them in Dungeons and Dragons, the adventure parties or whatever, and tried to predict when they were going to like make a raid on the castle or something like this. So anyways, this is another kind of fun. And then since we're at Google, in a lot of ways, the big $200 billion idea of Google is, I think people thought about, before Google, with Alta Vista and all, I don't know if people remember all this stuff, if I'm too old or whatever, but there, you can think about just forgetting about links, just thinking about just pure text documents and words. You can think about those like as graphs, where words and documents are nodes, and occurrence, like a word occurring in a document, is a connection between the two. And that was sort of how the traditional search engines worked. Realizing that a link was a very strong signal of kind of a vote for authoritativeness was kind of the key insight, which had a dramatic improvement on the quality of the search results. That's of course since been copied by all the other search engines, and now the basis of competition has shifted to other things. But and then of course, besides just that one insight, there was a lot of interesting math about how to propagate that authority through the graph, and so that's another application of graphs. And then I just had to put in a for the nerds here, XKCD contest. So another practical application of graphs is dating, I guess. Okay. So how do you build graphs? So I'm interested in, my primary interest is in sort of startups, and a lot of the most interesting internet, and particularly internet companies. A lot of the most interesting. A lot of the most. Wait, now this. Oh, no, all right. A lot of the most interesting internet companies, in a lot of ways, involve graphs, and so if you're a startup person or you're an investor, one question is, how do you build graphs? Like, how do you get started? A lot of graphs exhibit what are called network effects, which is, they get more valuable to each user as more users are using them. And so that is a double-edged sword. It's great if you're really big, and it's really bad if you're really small. And so, one strategy, a lot of this stuff, by the way, if you're curious about it, a lot of these are things I've blogged about, like bowling pin strategy and things, where I kind of go into more detail. But the bowling pin strategy comes from a book by Jeffrey Moore called Crossing the Chasm, which is a great book if you haven't read it. Which is basically, the idea is sort of that the utility of the utility of a network is proportional to kind of the coverage you have within that graph. So obviously one great thing to do is if you can just get a lot of coverage. If you can't, another thing to do is to sort of shrink the graph you try to cover initially. And so you kind of think about like where Facebook started, and they started at Harvard. And, if you think about, I don't know how many students go to Harvard. Let's say a couple thousand people were on the network. Let's say 50% of Harvard students were on the network, and let's say that was 3,000 people or something. once you got to 3,000 people at Harvard, it became useful to everyone at Harvard, or a lot of people at Harvard. If those same 3,000 people were randomly distributed around the country, it probably wouldn't be useful to anyone. So it was very important that they were within that. If you kind of think of the social network as these clusters, it's very important that they sort of attacked one cluster initially and were useful in that cluster. And the second important feature of Harvard or whatever was that there were sort of what they call spillover effects, which is that people at Harvard were friends with people at other schools because you don't want it to be completely selfish. So what you kind of want is a cluster that's small enough and contained enough that these people want to interact with each other and they get utility when you have a certain kind of critical mass of coverage, but not so isolated that they won't then spill out over into other areas. And by the way, if you read the book Crossing the Chasm, it's actually a book that's mostly focused on like B2B enterprise stuff. And it applies just as much to if you're selling healthcare billing software as if you're selling trying to build a social network. And it's one of probably 2 or 3 business books that are actually worth reading. I highly recommend it. Okay, another strategy is you find a cluster within existing graphs. So in the 90s, a lot of people thought dating would be sort of a winner-take-all market. They thought it would be like eBay or something where like or maybe like social networking seems like it is right now. It turned out later on there were all these sort of niche dating sites. JDate's one example that was successful. There's just countless now. You can pretty much, if you can think of a human attribute, there's probably a dating site, a successful dating site associated with it. And so it turned out that dating was not sort of a uniformly connected graph, that there are all these sort of subclusters. And that wasn't obvious at first. And so like the lesson here is if you're thinking about doing a startup or you're thinking about launching a product, when people assume that it's sort of a market is a winner-take-all, fully connected graph, question that assumption and, there might be an opportunity. So here, what I want to talk, so the idea here is that on different these are all sort of marketplaces, which are kind of like graphs, and the sort of salient point is that on some of them the types of nodes are homogeneous, on the other the types of nodes are heterogeneous. So with OpenTable, you have restaurants and you have people that want to go to restaurants. They're very distinct. With Skype, you have people just talking to each other, and there's there's no sort of buyer and seller or something. Another example would be, a sort of a straight dating site versus like a gay dating site where they're heterogeneous or homogeneous. And then, with Google AdWords, you think about advertisers and publishers. That's actually, maybe that should be in hybrid because actually a lot of advertisers are publishers, but it's different. I mean, sort of different. A lot of people say that the reason eBay sort of got going initially was actually a lot of the buyers were also sellers. Obviously that can't work with things like OpenTable. I think one of the interesting things, like when I think about, when people come to me and talk to me about businesses that are where they're heterogeneous, in almost all cases, there's one or the other side that's much harder to acquire as a customer. And so, for example, in the case of OpenTable, it's the restaurant. Well, I mean, there's always you need a critical mass of restaurants to get people to want to use your website. But the restaurants initially were very hard, and so what they did is, I have a blog post about this if you're interested, called the Ladies' Night Strategy, which is just basically just taken from what bars do, which is they have Ladies' Night because they've decided, a lot of bars have decided that for whatever sociological reason, it's harder for them to attract females than men to the bars, and so they offer incentives to sort of the harder side. OpenTable went out and gave out free kind of CRM systems to restaurants and did other sort of incentives to kind of get them initially on board. In the advertising space, typically the publishers are much harder to get and the advertisers are pretty easy to get. And so, I think if you're ever thinking about a startup or a new business or something like around these areas, it's always like you should always ask yourself sort of which is the hard side and what can I do to sort of incentivize that side. All right, graph wars. So there's been lots of interesting battles between graphs, and I'll talk briefly about this. This is a message on Google's export page when you tried, this is a screenshot, when you try to export your social graph to Facebook, and it says, hold on, are you super sure you want to import your contact information to a service that won't let you get it out? No, I think this is, Google's a company which has always been pro-openness, and this is probably, there's probably part of that sort of consistent with that theme. But there's also, you could argue, business reasons behind it. And so there's something called Metcalfe's law, which not only is it not a law, it's probably not even true, but it's sort of interesting. It's basically that the claim is that the value of a network, also, never mind, I'm going to say, all right, I was going to say Metcalfe himself, but I won't because I'm on video. The claim is that the value of a network increases with the square of the number of nodes in the network. The more people the more people have fax. Every time there's someone gets another fax machine, my fax machine becomes more valuable. It's directionally correct, right? I mean, like it makes assumptions like every person's connected to every other person. Like, in fact, that like if some random person I'm never going to speak to gets a fax machine, doesn't actually make my fax machine more valuable, but directionally it's correct. So the idea is sort of that the bigger, the networks grow with the square of the number of nodes. And so sort of a corollary to that is that when you think about two networks interoperating, the smaller network stands to benefit more than the larger network. So if you're interested, I have it's called the Interoperability of Social Networks, a blog post where I actually walk through a little math, very, arithmetic or whatever, but just to show the example. But we saw this sort of play out in the early 2000s with AOL Instant Messenger. I mean, it sort of seems funny now, but there was like the IM battles of the early 90s or 2000s, there was Yahoo Messenger, MSN, whatever it's called, MSN. Google released chat and but AOL Instant Messenger was the biggest, and everyone else wanted to interoperate, and AOL didn't because obviously for this reason that they had the biggest network, and clearly when you're the new person, you're like, yeah, that'd be great, I want to be open. So it's a very similar thing going on with social networks. When you're like Facebook, they claim to let you export your social graph, but really it's like you download it in like some CSV file or whatever. It's really not like meant to really interoperate with anything. So when you think about sort of, I mean, now the shame here is, of course, it'd be great for users if these people all got along and interoperated. Sometimes, I mean, this is, it depends on your political orientation or something, but some people would argue this is a case of market failure where it is actually, beneficial to have government regulation, and this has been the case in like telecommunication and other areas, because oftentimes you just simply have there's simply no incentive for these large, kind of huge network effect monopolistic companies to ever interoperate, and it hurts consumers and hurts competition. But I don't know, my libertarian friends think everything works out magically. So, this is the graphs here are meant to represent sort of the rise and fall of social networks, Friendster, MySpace, etc. There seemed to be a pattern where social networks would rise, they were cool, and then like your mom would get on it, and like you'd start like friending people you met at a conference, and pretty soon there was like this sort of natural decay. What Facebook did, which was kind of brilliant, was I don't know when they really were in the cycle here. I'm sort of inventing a little bit here, but what they basically said is, what, it's not good for us to interoperate with Google, let's say, but it is good for us to interoperate with lots of little companies and basically build a platform. And so this is sort of Zynga and all these other people built on. So they introduced their app platform and Facebook Connect, and through that have now sort of really entrenched themselves in the plumbing of the web in a way that it would be very hard to displace, even if the network sort of decayed. And so that was probably a brilliant strategic move, and I think it all goes back to these kinds of basic graph principles. So, okay, so now I'm going to do my self-promotional part, talking about taste graphs. So I like this game Carcassonne. I actually blog about it if you're interested, and I challenge anyone who'd like to play me. It's a German board game. When I go to the Apple, they have this recommendations, this genius thing they have, and they says because you like Carcassonne, you'll like Train Conductor or something like this. Well, Train Conductor you can kind of see like superficially, like it's like they're both tile games, but actually it's like I think it's lame and like it's nothing to do with this. And this is like this cool asynchronous strategy game, and Train Conductor is not. So what I did instead was I said, okay, let me go on iTunes and click on Carcassonne. I look at all the people that gave it 5 stars, and then I went through and looked at those people, and I found like 3 people that they like. So these are my 3 favorite iPhone games, and I found like 3 people that had those 3 as their favorites. And it's kind of a weird 3. Like Enigma is like a physics game, Modern Conflict's like a RTS, and Carcassonne's like a asynchronous strategy German tile game. I mean, so it's like the fact that these people, so basically the idea was there's these like doppelgangers, I don't know, where, like in Nebraska or something, who who have like this weird identical taste to me in iPhone games, and maybe like they have totally different tastes in restaurants and totally different tastes in everything else, but they were like, and so of course, like when I looked at their 4th and 5th game, I thought, well, that's really, really interesting, because like, who has this like exact vector? So that's kind of like, that's sort of the motivation behind Hunch. I forgot to also introduce Hugo, Lou, and Matt Gaddis here from Hunch. Hugo teaches computational aesthetics at MIT. He's a PhD from MIT, and Matt's also at MIT, and they're our chief scientist and CTO. But this is sort of our I think our basic insight was that there's sort of value in this sort of notion of what we call a taste mate, or this sort of taste similarity. I don't know what that is. So what are some of the challenges when building kind of a taste graph? So there's something that's sort of famously called the cold start problem in recommendation systems. The cold start problem is sort of this paradox that, what happened? That when you want to provide the best user experience when someone first comes to your website, you have like 3 seconds to impress them. But for any system to give you good recommendations, it has to learn about you. And so there's sort of this tension between the two. Netflix, I think they just have such a great product and people love getting their movies and et cetera, that they just sort of say, hey, if you want to get recommendations, you're going to have to rate a lot of movies. That's their kind of answer. Amazon sort of does it based on like kind of popularity, and they kind of learn about you and they look at what you bought and they do other kind of tricks. Facebook basically just assumes your taste, when they show you ads and other kinds of things, they just sort of assume that if you're friends with somebody, you have similar taste to them, which is, probably directionally correct, but not, completely. Our approach has been to sort of suck in lots of data sources, and so for example, I'll just give you an example. So for example, so we have, let's say we want to predict somebody's political orientation. So we go and we look at like the Facebook and Twitter graph, and we have known points on the graph. We have people who have Twitter or Facebook connected into Hunch and answered questions about their politics. So we've got like, let's say 1 million-ish of those people. So we have sort of 1 million known data points, and they're all spread throughout the Facebook and Twitter graphs. And what we do then is we do the sort of taste propagation, we call it. So what that is now I can't go to the next slide. I don't know. All right. So every presentation has. You can put a man on the moon, but we can't get a PowerPoint to go. All right. Well, I think there we go. So what we do is we take. So if let's say I follow Glenn Beck, we know that I'm a right-wing, whatever, who follows Glenn Beck, and. Well, wrong. This is our cool video. Wait. So we know so I follow Glenn Beck. Or let me just keep it. I follow Barack Obama. I go to Hunch. I say I'm like a New York liberal or whatever. And then I follow Barack Obama. And then a bunch of other New York liberals follow Barack Obama. And then what Hunch does is basically says, okay, I assume people that follow Barack Obama are politically liberal. And then we have a new user come along who is not a Hunch user, but they follow Barack Obama. And so it makes the assumption that that user has that political orientation. Now what we do is we take that that political orientation is one of about 80 dimensions that we do it on. We do it on like, your food preferences, your music preferences. And so each one sort of independently, think of it as like kind of flowing through the graph. And this is just kind of because it looks cool, but this is this is a visualization of kind of how it works. So these are like people following other people with the arrows here. And so far we don't know. Then we find out they're conservative and the red are conservative and the blue are liberal. And then Matt's magical algorithm spreads them out and propagates the taste to the appropriate people. So one of the interesting things, this is if you look at the academic literature on this problem, it's something that, it's like most, I guess I used to work in like finance, it's like most academia, like it's like great in theory, but then like when you actually, they don't take into account the fact that it takes like, it would take a supercomputer 18 years to run the algorithm or something. And so like one of the big problems that we've worked on and solved at Hunch is being able to do this in real time. So we can take a brand new user and fit them into the graph in real time, and things like that aren't generally considered by the kind of academics. So I think there's some interesting intellectual property there. So we'll go to the next slide. Okay, so why would you care about this? On our current site, we're about to release like a major new launch with a whole bunch of new features, including a mobile app and a bunch of other things. Current site, you kind of think of it as a little bit like Netflix for everything. It's sort of, we make predictions about what you'd like, but it's not just for movies, it's for anything. It could be an iPhone game or, this is our actual predictions of things I'm going to like, kind of like Words with Friends and hate 90210, which is true, probably. We have deals with a bunch of other websites where we have a gift app where we predict, you log in on Facebook and we can predict what your friends would like, what gifts they would like. That's where our cold start problem is particularly valuable because we've never seen your friend before, they never come to Hunch, and we can make predictions. We're working a lot on mobile. Obviously mobile's a really interesting area and we think is particularly useful. A lot of the stuff, I think around kind of the future of mobile search and discovery is going to involve kind of understanding people's tastes. So we think we play an important part in that. And then actually, I just threw this in here. This was last weekend. There was Music Hack Day at General Assembly, where a bunch of people came together and did some cool stuff, including some stuff with the Hunch API, which if anyone here does hacks on APIs, I encourage you to try it. It's free for non-commercial use and probably cheap for commercial use if you're friendly to us. So UZAC is, it looks at the Foursquare check-ins at a venue, and then looks at their Twitter names and cross-references them to their Hunch taste profile, and then decides what music should be played at that venue, which is pretty cool. And then Automatic DJ, there's a company called Face.com, is really cool technology, and I'm not affiliated with them, but I actually think it's genuinely cool. They do face recognition, and it works really well. It's like shockingly well, and figure out which of your friends you're looking at, and then they cross-reference. So Automatic DJ cross-references it with a Hunch database and decides what music to play. I think we're actually going to build it so like we have a webcam at Hunch, and as you walk in the door, it starts playing like you walk in, it's like it starts playing Bohemian Rhapsody or whatever. So it's kind of futuristic. It's cool. All right, so now since we're at Google, I thought I would just toss in some random stuff about Google. Well, I think this is, to me, this is an interesting question. People talk a lot about Google and Apple building social networks. People have speculated about, Apple has in some ways a social network. They have your contacts. There was this whole thing with, Google Buzz sort of assuming, kind of implicitly making the assumption that your contacts were a social network. I don't really have an answer here, but, I think looking at my contact list and my phone, it's you have situations, you have everything from the fact that you may have like a plumber or something, so the people you communicate with are not necessarily the people that you are friends with. I don't have an answer, anything really smart to say about this, except that I think it's going to be a big issue going forward because you're going to have all of these people compete, clearly who want to build giant social networks and who have incredible communication networks, and kind of going from one to the other is going to be a big, interesting challenge. All right, and I just wanted to, one last thing. So this is actually pretty cool. If you're logged into Google and you type, you go to Google ad preferences, I guess if you Google ad preferences, there's this page which shows you what Google thinks your interests are, and this is for the purposes of you being able to opt out of advertising. I just thought I think it's just inherently interesting, like sort of fun to see what it thinks you're interested in. And separately, Google has a new thing called Hotpot, which is pretty cool, which is a thing where you rate restaurants. It's a little bit like Hunch, like you rate restaurants and then it predicts what restaurants you'd like and overlays it on the maps. And so sort of part of what we do is, let's say, for example, we see here you like classical music, yoga, poetry, and hiking. What we do, and this is kind of part of our core thesis at Hunch, is we can say, because you like classical music, you're going to like Mediterranean food. Because you like camping, you like seafood. Because you like poetry, you like sushi, etc. So, like, kind of a lot of our thesis. So there's something called the if you read so people know the Netflix challenge, which is like Netflix offered $1 million for people to improve their algorithm, and there was something called the Napoleon Dynamite problem, which was there's a New York Times Magazine article, which if you're interested in recommendation systems, I highly recommend. Which is basically all these researchers were saying they could predict, all sorts of accurate things, but there were certain particular movies that seemed to elude all their predictions, and Napoleon Dynamite was one of them. It actually turns out this movie, What Women Want, is the hardest movie to predict. It's a movie starring Mel Gibson where he can where he can hear the thoughts of women, and I think it's like depending on whether it's either like highly misogynistic or romantic or something. I don't know, but it's like, but that's actually the hardest movie to predict. So I want to have like a party where we watch that and Napoleon Dynamite and like all the I don't know, and I guess I don't know who to invite, but anyway. So, but part of our thesis is that a lot of these that hunch is that a lot of these systems so far have. Like the reason you have the Napoleon Dynamite problem is not that, are people inherently unpredictable? Like, is it impossible to predict someone like Napoleon Dynamite? Or is it just that our belief is that it's the fact that they've limited the data set, the input data set, to simply what movies you like. Like, it turns out and I actually have data for this, if you ask questions like, it turns out the highest correlations, and if you can read it here, are, have you ever egged a toilet papered house? Is highly correlated with liking Napoleon Dynamite. Do you know which music group uses the line "Tin Roof Rusted"? It's B-52s, I think. If you know that, you'd like it. And if this T-shirt, "You're retarded," and "you're" is spelled Y-O-U-R. If you find that basically ironic or funny, then you'll like Napoleon Dynamite. And if you find it offensive, then you won't. So there's all sorts of. I'm using kind of whimsical examples here, but the point is, you can actually predict Napoleon Dynamite. You can predict all sorts of things. We believe that people are much more predictable than it's actually kind of funny. Like some of the stuff if you remember during the campaign, the last presidential campaign, John McCain accused Barack Obama of being an arugula-eating liberal. So we thought, okay, well, is it true? Do liberals eat arugula? Well, it turns out liberals eat arugula and conservatives eat iceberg. It's actually one of the kind of depressing things in doing all the statistical analysis of people is that a lot of these stereotypes turned out to be true. People that like Mac see themselves as more individualistic and like to dance and I don't know, all this other stuff. But like, so that's kind of it. And I think I don't know, Q&A or Q&A. Okay.
Chris, thank you. So in theory, we had two mics, but I'm holding one of them, so we'll see if we can figure that out. But if you have questions, so that everybody can hear, you can come up to one of these mics, and maybe I can run back and forth. And that way, everybody will be able to hear your question, and Chris can answer.
Thank you very much. That was really interesting. My question for you would be, do you think that you could predict people's preferences in food? And what sort of input data would you like to see in order to predict that type of accuracy?
Foods turns out to be very predictable. We actually have, if you're interested, what I'll do after this is I think they're going to put the video on YouTube and I'll blog about it and I'll put some relevant links if you're interested, cdixon.org. We have a bunch of reports we've done. It's kind of just for fun to show off the data or whatever. Food turns out to be an area that's quite predictable. So I don't know, Matt, do you have anything to say about food in particular? Or?
No, I mean, most of the stuff that we blog about is similar, like the, Rula,
Yeah, it's mostly like this sort of, these, it's funny actually, you can tell, like, you can basically ask people like 4 questions and like, it turns out, that's actually one of the interesting things we've discovered is with 20 questions you can predict like 95% of people's basically answers to anything. And probably with 5 you can do, like, what kind of fries do you like? Like, what kind of fries do you like? Do you like McDonald's or do you like those like Belgian ones you dip in mayonnaise? So that trend's conservative, for example. I don't know. Are you conservative?
It's funny. The reason why I asked is because about 4 years ago, we did a large analysis of the data set and tried to figure out, what in the audience, what sort of food people would prefer. And we presented the data, and then 4 years later today, we know that what we presented we were wrong with. And it was like really hard for us back in the day to actually look at the data and understand what we were actually wrong. And today I recognize the challenge and really calculating it correctly. So sometimes tastes are really a little subjective and really hard to prove. Right?
Yeah, I mean, so one of the things we've done, I was talking to someone, one of these location-based startups, and they were like, how should we think about like check-ins versus likes? How do we weight them? When you think about like building a recommendation system. And I mean, my view is it's not like the answer is like 0.6 or something. Like, it's not like some a priori constant that like is going to explain all. Like, so basically, what our approach has been is a very empirical approach. So what we do is we build systems that we think will make good predictions, and then we actually run tests. So we for example, run ads on Facebook, which are deliberately around the world across different demographics, and we test. We say we think you'll like arugula or something, or actually we ask them like, do you like this or this? And we have this called the prediction game, and we run tests. So we actually do it empirically, and I think that's like the only way to really do these things. Is you can use all this sort of fancy algorithms and fancy data and everything else, but ultimately the way that you measure these systems is empirically. And I don't know if you want to get statistics here, but doing kind of cross-validation and all these other kinds of things just doesn't really work. It's not really that reliable. There's all sorts of biases, and that the only really real way to test. So we've done a lot of. So we know, for example, that. We can take an arbitrary Facebook user and with 85% accuracy basically predict any question in our database, like political orientation, et cetera, just simply from their Facebook profile, right? And then if they answer questions, we can get higher. A lot of these systems, like I have a blog post called something like machine learning is really good at partially solving every problem, which is like, if you look at like the Watson thing the other day, like, I don't know what you guys think. I wasn't that impressed because it's basically like, well, yeah. First of all, like you play in a game where whoever pushes the buzzer faster, and like that's kind of like inherently biased towards the machine. But secondly, basically, it's like most machine learning things. Like you can, I built a system. I could do something like 10 minutes where you type the question into Google, you take the top result, you push the buzzer faster. You're probably going to beat most people just that way, right? I mean, like, and then they just like tweaked it a little. I mean, I'm sorry if someone here worked on Watson or whatever. I mean, basically, that's where they started, and it took them like 3 days. I've seen this a million times with machine learning. It took them like 3 days, and then they spent the rest of the time like, oh, crap, what happens when, it's in travel, it doesn't work as well. Let's make a special little trick for travel. Oh, let's make a special. And so what happens is it takes you 3 days to get to like 80%, and then it takes you like 3 years to go to 88% or something. And then that's why it answered. It said what U.S. city has two airports named after World War II battles, and it said Toronto, right? I mean, it's like something like, it's like, but like that's why it failed, because it's one of these things where it's just like, it's basically putting into Google and whatever. You had some random thing happen. I don't know, but am I being unfair to Watson, or you agree? All right, okay. So
empirical for 1,000.
I'm sorry.
Empirical for 1,000. So if you take your empirical model and actually go into the field and test it empirically, ask people, do you like cauliflower, and then give them a taste of something else. Can you comment on?
Well, we don't have the ability to. I mean, we're doing everything online.
The so-called Pepsi challenge test, if you would, right?
So you're saying to actually give them
Yeah.
what they actually like. Yeah, I mean, look, one of the biases that systems like ours have is there's a couple of interesting, you're getting at, I think, some different biases that these different methods have. So for example, if you ask people what kind of car they want, we call this a Lamborghini problem, right? They always say the Lamborghini, when in fact they realistically are going to get the Camry or something, right? And on the flip side, if you look at where people actually check in on Foursquare, the reality is they check in at Chipotle all the time, but you don't want to necessarily recommend Chipotle to a Frenchman coming to New York for the first time, right? I mean, so you have these biases in both directions of both on the one hand, a bias towards the more, extravagance, on the other hand, biases maybe towards the more mundane or something. There are all sorts of issues like this, and there's no, I mean, we don't have the resources or the wherewithal to get people to physically eat cauliflower, but but we sort of try to adjust for these biases in other ways.
But it might be seen as a narrowing rather than broadening of thinking and thought, and might also be interesting to look at age-adjusted stuff and aspects like that. A second question, what are the other 2 or 3 favorite business books? Or books
Information Rules, which actually is a Googler, Hal Varian, I think, co-authored. It's a phenomenal book. It's the only book that real economists talking about information. Every other information book is just I'm sorry, I just find it to be platitudes or something. And then what else do I like? Clay Christensen, Innovator's Dilemma. That's a great book. That's that basically. I mean, that's the whole he has this whole thing about why it's a kind of a mystery. Why is it that every 6 years you look at the list of internet companies that are today that dominate, and 10 years ago, and it's a completely different list. How the heck does that happen? How do they miss every and that's sort of what he's trying to do. It's kind of a mystery, right? Shouldn't you see these trends come? There's huge teams of people at Microsoft and Yahoo and all these people trying to look for the next big thing and tracking it and doing everything, and they have the best resources in the world. They have billions of dollars, and they just miss Google, they miss Facebook, they and so Christensen has a whole interesting theory about how this sort of works, and a lot of it has to do with the fact that a lot of these interesting new technologies sort of start out looking like a toy, as he calls them. So when you go back and you look at Western Union, dismissed the telephone as a toy, and they passed on the rights to buy it for a very low price because at the time it only went a mile, and their customers, the Western Union customers, were all business customers who had to transmit important information from New York to San Francisco. What's this toy that you can call your friend and talk a mile away?
Keep it running, right?
The basic premise of the book is that people's demand for technology is sort of like this, and technology always kind of gets better like this, and you've got to sort of you've got to, of course, realize that the phone's going to start going farther and farther, and that all sorts of things are going to so he goes through all these really interesting examples. A lot of it's focused on hard drives, and it gets very technical. It's a very interesting book, and it sort of explains why this can how can this happen, and that these new things come, and one of the things he says is the next big thing will look like a toy, which is kind of interesting. I think I actually was working at a venture capital firm when we invested in the first round of Skype, and that was exactly what remember the telecom company's exactly saying that this thing's a toy. At the time, it was a toy. It was garbled sound. It worked. It dropped calls half the time. But of course the broadband, the stuff would get better. Of course that their technology would get, et cetera. It just the trends were all in its favor. I'm not saying we knew it was going to be the next big. We got lucky. Also, there's a lot of other things that happened, but.
And their cloud quality got worse.
I'm sorry?
And their cloud quality got worse.
Yeah. Yeah, and it became a non-interesting business to them, so they didn't care about it anymore or whatever. But anyway,
So I had a question about one problem that I'm constantly running up against is, you have 2 sort of preference sets, and you have an inflection point between them. So the preference sets look very near according to your algorithm, right? And then something minor changes and it causes, and then the users has wholly different preferences.
So you're saying like a mood change on Netflix?
Yeah.
The interesting thing on Netflix, right, is that you guys correct me if I'm wrong. People are only one of the challenges is people are only self-consistent on their ratings, 90% of the time or something. So in other words, you ask the very same person to rate the very same movies the next day, and they rate them 10% of the time differently. So how the hell can a computer do better than that? You can't do better than the person, right?
Right.
But and a lot of it's also mood and I'm in the mood for a thriller right now. I just had a bad day. I want a romantic, like those kinds of things are big challenges for these kinds of systems.
Yeah, so like I'm thinking where you have like two solution sets that are very near, and then what happens is something minor changes, whether or not their preference sets change over time or anything, but two people very close to each other on like 90 different things are suddenly very different from each other on one thing because there's one minor other change somewhere else, and a lot of trending and continuous like methods of trying to figure out what people's preference sets are seem to not be able to take this into account very well. So I was wondering if you had any tricks.
I think I have to phone a friend on this one there. Here.
It really depends on kind of like the methods that you use to generate recommendations. I think nearest neighbor type algorithms have the kind of problem that you're talking about, where like my nearest neighbor is this person because I'm so similar to him, and like anything that he does you also recommend to me, but then all of a sudden like you figure out he's not your nearest neighbor anymore, and like what happens, the system has all these like sort of local artifacts just because of the locality of the data.
Right.
But we treat things a lot more statistically and a lot more like we think about things in terms of like aggregate correlations, not really. Chris's examples were, where he's showing like how it kind of found his taste mates and then showed people similar to him. Mm-hmm. That's just sort of like an example of how one might use the graph to improve recommendations. But in reality, our algorithm is a little more advanced than that.
Cool, thanks.
Just wanted to add to that. My group at the Media Lab where I did my PhD is Patty Maz's group, and collaborative filtering actually came out of our group earlier in the group's life cycle. And people ran into this problem a lot because you use clickstream data, which is within one domain.
Right.
And the problem is that what you realize is that it works really well in this domain. The moment you try to cross an inflection point or leave the domain, it breaks. That's because you're stuck in a local maxima. You're training against a local maxima.
Yep.
And so what we're doing at Hunch is we're really doing open domain recommendation. And so the idea is that a lot of our features, sure, we use cameras, ratings to predict camera ratings, but we also have things like personality features, behavioral features. Did you have a goldfish when you were a child? And a lot of these features don't change as much. They're not as they're not as vulnerable to reporting bias and just errant reporting. And the hypothesis is that we can be truly broad and agnostic with respect to the feature set. Then you can sort of avoid these kinds of problems.
Nice. It sounds like you need a lot of computational power for that, maybe. Well, I mean, like it sounds like you're.
Did you work for Intel or something?
I wish I could tell you something right now. No.
Nice.
Do you have any recommended reading? By any chance?
Talk
afterwards.
Yeah, add it.
I blog about this. I'll add it to it.
Yeah, if you want to read my dissertation, I wrote a dissertation on taste modeling. So
Nice. Thank you.
Hugo has a thing called the Synesthetic Cookbook, which is it was like in the New York, all these LA Times, and he's like smoking a pipe. He's like, we make fun of him for it. But you type in your mood, right, and it finds recipes for you according to your mood. When it writes recipes. He has another thing. One of my favorite things he did is you roll over any text on the web, and then he shows you what each of the Supreme Court justices would say about that. And so it's like Clarence Thomas is like, that's disgusting. And then like, anyways, all right, so.
Thank you for the talk. And I wanted to ask you if you could tell us more about how you went from the theoretical analysis to the practical use of all the graph theories. Because you mentioned that one of the biggest challenge was that when you take algorithm from the research world, it may take 18 years to compute or something like that.
I'll let Matt talk about that because he actually did the work on that.
So you mean specifically like kind of what changed with our data as to what's typically in the real world? Yeah, I mean, so basically, typical, academic machine learning problem is, they all have the same data sets. It's sort of like, they collected this data set in, 1990 or whatever, and it's just, you train on that data set and maybe you leave some samples out, and then you try to go predict, those samples, and it's very, it's very contrived in that respect. Whereas in real life, you have new users who've never seen anything before. You have samples that come in. You can't always just build a statistical model, for a batch set of data and then just, have users come in on the fly and sort of immediately adjust not only your model for that user, but your model for the things that user rates. So there's basically you have to adjust to a much more dynamic world when when you're talking about users that come to a website, because it's not you can optimize all you want on a specific data set, but in reality, like no data set is like that. So.
I see. And just on the technology point of view, is it did you have to use some specific type of hardware or specific architecture to be able to?
Yeah, well, algorithmically, we spent a long time sort of researching different ways to sort of fold in, iteratively, take sort of models that existed. So we're using some of the latest research. Take a lot of sort of algorithms that existed for collaborative filtering, and taking those and just being able to make them work real time. So just adjustments to the algorithms to sort of fold in new data so that they can sort of the models that you generate sort of evolve over time, as opposed to just get generated in batch modes.
In terms of talk about the hardware. It's cool.
Yeah, I mean, well, the hardware is we have sort of it's a huge computational problem. It's not really related. It's not really because of the dynamic aspects of it, though. It's just because by crawling all these data sources and folding in all these different domains of data, we have over like 30 billion edges now, and that's even if you have a very compact representation where that's only like 18 bytes per edge, that's still hundreds of gigabytes of data. That you need to actually, not just run through once, but these algorithms have running times. Yeah, and that's another thing is, traditional databases, have a kind of different view of the world where, graph databases, the nodes are highly connected to each other, and the algorithms, in order to, figure out the taste profile of a user, you need to know all the things that it's connected to in real time, and you can't really partition that data very well because everything's so well connected. So it's not like a traditional kind of thing like at Google you can use MapReduce and massively parallelize it across distributed network. So we have things like supercomputers to load all the data up in hundreds of gigabytes of memory and then process it that way.
Thank you.
Hi, I want to go back to the inherent bias in trying to graph certain kinds of data where people's assumptions are just wrong going in, and how do you overcome that? For instance, if someone says that you can't do business in a particular developed country, but they've never been there, even if you present them with data that says this is a good place to do business, and when you try to graph that, I'm sort of confused as to how I can overcome that inherent bias that this is not a place to do business because they don't know anything about the place.
Well, I think, I mean, maybe the way I'll interpret that, I guess, question, maybe tell me if I'm wrong, is there's two problems. There's giving recommendations, and then there's convincing people that the recommendations are correct.
Right.
And I don't know about your particular example, but I'll just speak more generally. I think that second part of convincing people is probably one of the harder and more interesting areas. So, like, one thing we've been sort of frustrated by is that we know that, for example, on Hunch, that if it recommends something that, that 95% of the time, if you go do 4 hours of research, you'll come to the same conclusion, but people don't believe it. So, like, how do we convince them of that? One way to convince people is, to have their friend recommend something, right? Like, that's sort of the Facebook approach. Like, hey, I trust Frank, and Frank said that Hawaii is a great place to vacation, and, there's that aspect, right? I think we're intrigued by this idea of Tastemates. If somebody, hey, this person thinks like me in all these different ways, and I sort of gain trust that way. Another way is to sort of give a set of reasons and sort of other things. But I think it's a big, interesting, open problem. I think if you look at like the existing solutions, like Apple Genius, they say you should download this because you downloaded that, like or you bought this, and I don't think it works that well, and it's not very convincing, and it's a really hard problem. I don't know. It sounds like you're talking almost more about just convincing human beings of things, and in real life or something? And,
Well, yeah, no, that's part of it, but I'll give you a quick example. I do a lot of consulting in developing countries, and if I say to someone, Ghana is one of the most digitally advanced countries in Africa, just saying that, even if I give them data, how do you convince an investor to say, this is a good place to do business that I can do?
I was just talking about, I don't know. I mean, that's a good question. I mean, I don't know.
No,
I mean, people are irrational, and I can't believe half of, I don't like 70% of the country think like UFOs are real and angels are
Right.
flying. I don't know. So what do I know?
Okay, no, I understand, and that's my question. No matter what statistical model I come up with,
Yeah,
it's still tough to say, hey, here's the data. These are facts.
I mean, it all
didn't
depends on
make
the
this
type
up.
of person you're dealing with, and I don't know I'm sorry, I don't really
Okay,
have a great
that's
answer.
fine.
Yeah, I don't have a great answer. But,
Okay, it's just
Yeah.
something
Yeah, I
to
know.
keep in the back of your mind.
yeah.
Hi, question. So obviously you guys build graphs now, and you connect people and things in different ways, social networks, their preferences, and there's many ways to connect. I was wondering if you guys had put any thought into, information, right? So, I mean, information, I think, is the ultimate thing that kind of like connects us all. At the extreme, this is the extreme, but at the extreme, I'm saying this and you're recording that in your brain, so it's, this information now it's associated with you and with me because I said that, right? I mean, this is an extreme, right? But more tactically, if I send an email to a friend, that same information is, here and there, and this is to the extreme tactical and, brute. But it's the same information in one place and the other. I don't know if you guys have put any thought into that concept of how information links things, people, and so on.
Seems like it's kind of a broad question.
Yeah.
I think Google's organizing the world's information, and we're trying to stay out of their way. I don't know. But,
Yeah.
Let's stay away from the steamroller.
But I'm not saying from a,
Yeah,
I'm looking for this perspective, but
I guess I'd need a more specific question. I'm
right.
sorry, I
So
don't-
I'll give you an example.
A follow-up, so if someone tweets something,
Right.
and you're looking at contextually,
Right.
what's in the tweet.
Right.
Yeah.
The actual. So like if
You're saying doing natural language processing or something?
No. Even but that's more advanced. But like
Okay.
more dumbed would be, you have a blog post and I copy and paste a piece of it and I do a quote in my blog. Say, right? We're not friends in Twitter, Facebook.
Oh, so you're saying, like, for example, what Google has to do to detect spam farms and things like this? Like, every time I do a blog post, there's like 1,000, or not me, but like when a TechCrunch does a blog post, there's 1,000.
No, but I'm not saying like for that purpose, but for the purpose of like how people and things are connected.
Oh, I see.
I'm not. I
Yeah.
don't know. I'm asking. So I guess the answer is like it's not a variable that you guys have.
Generally, like in our particular approach, I'm not saying there aren't other approaches that would work.
Yeah.
Our particular approach has been very statistical, and we've sort of are skeptics of a lot of these sort of language models analyzing tweets, et cetera. But so but that doesn't mean it can't work, and we just you got to.
So even statistically, say
Right.
analyzing mail and Gmail, and
Right.
number of times a particular word or set of words show up in certain numbers of emails, and how many times that's looking through your social graph, and how many times that's happening with your friends, and looking through
I mean, Hugo did his thesis on like sentiment analysis in email, so I guess if you want to right? I mean,
I don't understand the question.
yeah, I guess I don't.
So this is my point. That's exactly my point. Like if you put a blog post, and I copy and paste a piece of it and I put it in my blog post, right? There is a connection between you and me, right?
Yes.
And that connection is not captured anywhere else.
Well, yeah, I mean, you can capture it by crawling the web and seeing the two. You can capture it by, there's like a company called Tint that actually like embeds your link whenever you copy and paste and intercepts the copy command. I mean, there's people trying to work on that problem a little bit, but it's not some, I guess it's just beyond our purview or something, but
Yeah.
I don't know, I'm sorry.
Do you guys take into consideration how taste profiles might evolve over time?
Oh, okay. Do we take? Yeah. Well, what we try to do is we try to focus on kind of. We kind of try to think of it as like there's there's sort of, I used to study philosophy. There's like like Aristotle would say, there's essential properties of people, and then there's accidental properties. And the essential ones are ones that persist throughout time. And so, there's sort of like, there's, the fact that, or I guess you could think of it also as just a scale of sort of the degree of persistence of each thing. So if someone has strong political beliefs, that tends to persist. The other extreme is like a mood or something which won't at all. And so we try to focus on things which persist and capture mood and other things in other ways. But that is a problem. I mean, there's sort of a natural, I think, with any kind of data set about people, there's just always a natural decay. People change over time, and that's just one of. I mean, we've faced this problem both in terms of people and in terms of. So we kind of think of the world as people and items. So items is like, so we want to be able to like say like you like this restaurant, and so we also have a taste profile for that restaurant. And those things change very quickly too. They go out of business, new ones come about, they change their menu, whatever the case might be, right? And so there's a constant problem with sort of data refresh. So it's sort of like, you have to think of, I think you have to think of a lot of these systems as, Wikipedia every day. Actually, another good business book, Clay Shirky's Here Comes Everybody. I remember he talks about how every day there's, 1 million instances of somebody vandalizing the website, and every day there's 2 million instances of people improving it, and it's like this constant sort of flow, like decay and rebuilding. And this is a feature of a lot of websites. I'm sure it's true of Google search algorithms. Like there's sort of this constant. And so I think that's sort of how you have to think about it. And so, but as a company, as a startup, the challenge is keeping the flow of data coming in sufficiently to kind of keep up with the changes.
I guess I was more thinking about like if you like medium-bodied wine right now, you might like full-bodied wine like 6 months from now because you've developed this taste. Do you have any data on that or observations?
Wait, I'm sorry, full body what?
So like acquired
wine,
taste.
Okay.
Yeah.
I mean, I can't offhand. I don't know. Do we have wine data? We know offhand, but.
In general, we sort of there's basically a weighting system to all of our edges, so to speak, right? So like you have an edge between like you come to our website and you liked wine, and so where we draw an edge from you to the medium-bodied wine. And then, so there's a value for that, which is, is it a positive edge or a negative edge, whether you liked it or disliked it. But then there's also sort of a confidence level associated with it, if that makes sense. Sort of if it was gathered from a weak signal or a strong signal. This might be also getting back to the previous question a little bit. How that you have sort of weak signals and strong signals, and you have to model that in your data. If you just saw somebody mention something in a tweet they might not actually like that. Like we treat Foursquare check-ins differently than someone explicitly saying that they like that restaurant. And so we just do that by, there's a lot of different ways you can model that, but in order to have something really simple that you can use across, all the domains that we try to accomplish, and we sort of assign a confidence there. And that actual confidence can decay over time. So basically, if you enter that 2 years ago, we can go through the system and sort of, decay that confidence level there. But it really hasn't been a huge issue for us yet. Like we kind of tackle these problems as they come, and like it hasn't been like we haven't gotten any complaints of people being like, oh, this data is stale or whatever yet. But because like Chris said, we're focusing on getting more of it and more of it and more of it, and like not like phasing parts of it out yet. So.
I was just going to add one more thing, which is that so you have taste, how much of that is signal and how much is noise? Right, so that if you are romantic, you'd believe that at some point your taste would converge upon your collective individual, right? And everyone would live in taste tribes in the future, and you sort of have a lot of reflectiveness about yourself. So one of the easy things we can do from a static shot is we can infer how much signal is there. So you can simply look at the coherence or dissonance relationships in the data, and see if they support whether or not you're likely to have stable tastes, according to what we know as stable from our static snapshot, or if your sort of tastes are in flux or underdeveloped, right? That's another way to look at it.
Thank you.
Taste tribes.
So I think we're just going to take one more question. I want to be respectful of our speaker's time and give them a warm welcome and send off. And then people will be free to kind of mix and mingle, and Chris may hang around a little bit more so you can ask some more questions. So one more.
Thank you. I actually had two questions, one following on that, but the first one is very simple. You pointed out that, so in Facebook, they make the assumption that people who are socially connected are similar, but you've gone the other way and looked at other features for taste graphs. So I was curious if your data showed the reverse, that, people who are taste mates are actually connected in the social network or not.
It actually turns out on Facebook that the things you like are vastly more predictive than
the people
who you're friends with, and who you're friends with is actually not that predictive.
Yeah, the weak ties, Facebook doesn't have.
It actually is not a very good predictor of taste.
Right.
I mean, it's, I think with the telemarketing example I used earlier, it's better than these like throwing, darts at a dartboard methods they used, in comparison. But yeah, we're talking, it's like, but it's very, you just think about, I don't know, like, think about your friends and their food preferences. Like,
I'm very curious to know if you can kind of come up with a 6 degrees of taste separation. It's like based on how close we are we always about 2 degrees away from someone?
Yeah, actually, one of the things, I was hoping to collect, we didn't have time, but I was hoping to get more data collected here, which is that's what I think they call the diameter of a graph, right? Which is how many degrees of separation on average. Cool. And I was hoping to do that both for Hunch, Facebook, Twitter, et cetera. Something I'd like to, maybe we'll try to run that analysis, but that would be interesting, right? Supposedly in real life, it's 6 degrees. I don't know. Wasn't that debunked?
It was 6. I think it's debunked, but
yeah, but
Facebook destroyed all statistics. The other question was kind of building on that, and this year there's been like a lot of buzz about gamification and game mechanics to influence behavior and things like that. So I was wondering, it sounded to me, I might have got this wrong, that 2 nodes in your taste graph have a lot of features that connect them and you weight all the different features. So I was wondering, does that give you insights into persuadability? Can you tell that, this is a taste that can be influenced? So I think it would be really cool for like obesity and health, right? I can just tell you, hey, Weight Watchers is not going to work for you. But maybe if you did go and join a gym, it might, based on the fact that you're tastefully similar to people like that.
Yeah, I don't see why persuadability couldn't be it may already be in our database. That could be an interesting report. Like
that would be very cool.
Yeah. So that's a good idea. Yeah.
Okay, cool. Thanks.
Okay, well, thanks very much for coming, and I'll hang around.